fun with this. Okay, so today's session, this is going to be really just a recap, a review session for everyone who hasn't had a chance to program in a while. Make sure that you all are up to speed with it. I'm just, pardon me, trying to figure out where my chat window disappeared to. What we're also going to be talking about in here, well, take a quick look. We're going to go through a couple concepts you guys should all be familiar with. There's like variables, if, else statements. We got lists, we got for and while loops, we got functions. We got one more on the list that's brand new, and that's called tuples. And so those ones you might not be familiar with, but they're quite easy to work with, don't worry. We also have the dot operator as well, which actually you guys already basically know. And then finally, we're going to jump into Pygame. Okay, let's get onto it. And darn it, I could not find my chat. I do not know why. I'll just have to live without that for now. All right, so how does this work? We're going to go and use the print statement for telling us stuff. I'm pretty sure that you all saw me in action using this yesterday. But just as a quick, simple reminder on how that goes, we're going to go and say, if we want to go and print something, we go print, we open bracket, and then we're going to go open quote and then close quote as well. We can go and type in our message, hello world, the iconic. And of course, we also use comments as well to go and point out a lot of useful information. I press play, I see hello world. Comments, nothing happens here. All right then. Does anyone want to tell me why comments are useful? I'm pretty sure this is all fundamental stuff, but I do always appreciate when someone who can tell me why comments are the most best thing since sliced bread. I realize I painted myself into a corner. There is no way for me to go and answer you guys if I cannot even see my own chat. There it is. I've had my chat buried this entire time. Comments, so we can read our code as humans, so we can be organized, so we can keep debugging. We can tell people who read our code what we are doing. Excellent, I am loving these answers. Yes, absolutely. The reason is that we use comments is because a grand majority of the time, if you're working on a big project, you're not writing code, you're reading code. And you better make sure you know what you are reading. Comments help so much with that. And yes, comments absolutely do look cool. Thank you, Mark, for that. And actually, ooh, there's a really good comment there that you can use comments to go and knock out a piece of code that you don't want. In fact, I'm going to do that right now. I'm going to press Control and slash, a keyboard shortcut, to go and knock out the line of code that I have currently selected. It's useful for me because it's going to give me some cleared space so I can keep talking about the next stuff coming up, such as variables. Variables, as you know, is your traditional container to go and hold values. I'd like to say that it's like a shoebox. You can label that shoebox with anything. That's your variable name. You could put anything inside there. So maybe you can put your shoes in there. Maybe you can go put any items you want inside there. And yeah, you can always go and choose the different types as well. The types being basically based on this number here or the following value here. The classic ones that we have are going to be the integer, the floats, which are basically the decimal numbers here. We got strings, the ones that have little quotes on the end, and we have Booleans, the true false family here. And as we're going to discover, there is technically an infinite number of types. Well, some people might not be looking at me too happily when I say that, but we're going to see that there's a lot of different types that you can go and put inside variables. Of course, that can't make sense. Nobody has time to go and punch out infinite different ones. So how's that possible? Well, we'll check it out later. I'll give you a hint, it has to do with objects. But quickly, just to make sure that we all are on the same page here, I'm going to go and type in just some examples. We got x equals 3. We got floats. We can go y equals 2.2, or another interesting one to pay attention to. You can go 4.0. Notice that little 0.0 there turns this into a float automatically. And then we got strings as well. We're going to type in, like, my name is Richard. And so you see that we have this quotes here on the end. If not, it'll be a variable, and that's not the best thing we have. And Booleans, excited to code. Absolutely, that's going to be 100% true. So there we go. We got a couple classic examples here. Moving on through next up. Got our if statements, we got our else statements as well. These are our classic ways how to make any code interesting. If it is raining outside, we're going to go and bring our umbrella. If it is not raining outside, it's going to say it is a nice day. I'm going to go and point out just something simple for syntax. It's something that we don't explicitly bring up to attention all the time. But when we go something like is raining equals true, you can either type out if is raining equals true, just like that. Print, yep. Or you can print out the equivalent statement if is raining. As long as this conditional here is somehow true, then there you go. It's automatically going to happen. So we see here, this is true, obviously. Or we can see that true equals true, which is also true. So there you go, just as a quick little tip on how you can do that. Of course, we also have our else statements. For when it is false, we're going to go take the other route. We're going to say nope on that. So I'm going to go knock out this piece of code here, Control/, or as DA has mentioned, Command/ if you're on the Mac computers. And when I press the play button on this, yes, we can definitely see very much, yes, we're going to go and have it is raining out there. I should have definitely bought an umbrella, but I'm kind of typing a little bit too quickly. If it's not raining outside, naturally, it goes down to our else statement instead. So with that, we're going to have the elif statements, which is short for else if. If it is not true, go take a look at the else statements. If that is true, we're good. If that is also false, go down to the next statement, check if it's true or false. So we take a quick look at this example here. I'm not going to bother retyping this entire example out, but we see that we have like our grade is going to be like maybe 88% after the last exam. What letter grade did we get? If your grade is greater than 95%, that's an A+. We didn't get that. So down to the next else if statement. Is it greater than 90? We didn't get that. Go down to the next one. Is it greater than 80? Yes, it is. You go and get your letter grade from there. Just pay attention here. The little detail is that if it's an if statement, you're going to flow down. If it's an else if statement, it's only going to go through one of the else if statements, or elif statements, if I'm going to be more correct with that. So if you make a little fumble, and well, what do you know, I'm typing it out. Grade equals 88, and I say if grade is greater than or equal to 95, print okay. I'm going to copy paste that real quick, just so that you guys don't have to watch me type this entire time. I just want to go and highlight a little bit of a difference here. If you're going to use two consecutive if statements, that is very different than if you use an if followed by an elif statement. There we go. We can see a full example here. Perhaps, in fact, I can even flip it upside down. I'm going to flip it upside down. I'm going to demonstrate here. If a letter grade is B, if the letter grade is B, I'm going to print, oops, not B, that doesn't make any sense. What am I talking about? 80 here. I'm going to print out my letter grade is B. Elif, if my grade is 90, I'm going to go and print out A. With the if and elif, only one of these happen. Or if I'm going to change this to an if statement instead, what happens is that this is a completely separate logical condition here, and it's completely unrelated. And you can see B followed with, oops, well, that's right. Obviously, I didn't get my 90% there. So I'm not going to get my A. You always don't want to see me scrambling forever. But you can see that if you have multiple statements, you're going to have them all chained together. Hopefully this is all review for you guys. But I'm going to keep on moving on here. Just going to give you a quick reminder that the equal sign is not the same thing as the double equals sign here. The single equal sign is the assignment operator. It is how you go and set variables. X is set to 3 in this example. Fruit is set to banana. The number of equal signs I have is set to 1, and you can print those all out to prove them for yourself. The equality operator is a 2 of them, and this is checking, is this true or not? So if the number of equal signs is 2, well, then we got our side equalness here. But that's not what we have, obviously. 1 is not 2. Let's prove it. Is single equal to double, true or false? Let's print it out. Let's see. I'm going to go and knock this comment code out just so it's not in the way. Same deal with all this stuff up here. And I'm going to go and jump down to here. Single equal versus double equal. What I want to highlight is that you can go into and like print 1 equal to 2. And this is a double equality operator here, so it's going to check. And it's going to print false, obviously not. What we can do here, we can actually go and make Boolean variables out of this. And so we can combine single equals and double equals on the same line. Is 1 equal to 2? Is assign the value of 1 equal 2? So you read this out here. It says, is 1 equal to 2? That is set to the value of, and I can even put some brackets here just to go and clarify that a little bit better. Take this, calculate that. We all know that 1's obviously not 2. That's going to be false. And then we're going to go and set that value, which is false, right into is 1 equal to 2. Print is 1 equal to 2. Press that, save that, run that. We see that it is false. Hopefully that all makes sense. Stop me if you do have any questions, though. Finally, last things I do want to go and highlight is the keywords and or. You use them in the English language all the time, so they're not that foreign to you guys. But you can go and chain those Booleans, those conditions together with your and keywords and your or keywords. So for those of us who might or might not be living in the middle of a pandemic right now, we got to go and take a look at some things here. If we are wearing a mask, which is true, and our distance is going to be greater than 2 meters away, we're safe. Obviously, if you're standing 1.8 meters away, even if you're wearing a mask, you're not staying safe. Keep that distance, keep that safety there. Got to have both of those true. In the meanwhile, the or statements here. When should you stay at home? Well, if you had close contact or you had a temperature of 37 degrees or both. So if you have one or both, or that's when you should be staying at home here. So stay safe, everybody. That's the moral of the story. With that, I'm going to go and flip you over to the first quick question. Time to go and get your brains working. What is this thing going to go and print? Okay, I'm seeing answers slowly trickling in here. Okay, I'm going to give you a 30-second warning. Wrap that up. I think 28 out of 35. That might be every 1, 2, 3, 4, 5, 6, 7. Yep, I think we've got basically everyone here already set to go. Okay, let's go and wrap that up. So what is the answer here? The answer is D, less than 20 and greater than 0. We're going to get both of those printed out. I see a couple people here have only printed out less than 20. Did you guys get trapped by that if versus that elif thing here? We don't have an elif. That is a completely separate logical question. I'm going to go and quickly work out the answer just so that you guys can see that for yourselves. So I'm going to pop that off to the side just so I can actually read the question while I'm in the middle of typing it out. And I do need to go and shuffle my screens on my other monitors so I can actually read it. Okay. So we got my num is equal to 4. Value is equal to 5. Those are just some generic variable names. Result equals my num times value divided by 2, I believe. Let me check. Divided by 2 plus 4. Naturally, this is just some good old-fashioned arithmetic here. So we know 4 times 5 is equal to 20. 20 divided by 2 is equal to 10 plus 4. That is equal to 14. And it's always a good check. If you can, Write this down as some debugging information here on the side, just so that you can follow along. Makes your if statements a lot easier. And so now we're going to also go and start printing out some stuff here. If result is greater than 25, we're going to print greater than 25. Hopefully I'm not making typos, I cannot tell. I'm going to copy this line just because I'm a little lazy. And if my result is lesser than 20, we're going to go and print out lesser than 20. Well, I'm getting a little bit sloppy about typing. Goodness. If the result is greater than 0, we're going to go and type out greater than 0. And finally, else print some number. We really don't know. And when we run this program, what do we see? We got everything coming as less than 20, but greater than 0. And oops, I got some old stuff here, so let's ignore that little detail. Why is this happening? Because remember, these if statements are completely separately logically evaluated. That else statement only applies to the very bottom one here. So if it is 14 greater than 25, we skip that, nothing happens. Is 14 lesser than 20? Yes, it is, print that out. Then go down here. Is 14 greater than 0? Yes, it is, print that out. So if you need a recap on that, just go back and take a look at that slowly, type it out, and print your statements out right at the top. Okay, back at it. All righty then, I'm going to go and presenter view, slide some screens over. There we go. We're going to talk about the next subject, lists and loops. These are going to be so useful in the future here. So basically, a list is a way how to go and store multiple numbers here. You always go and create them by using those square brackets in Python. So numbers is a list of numbers, and we're going to go square brackets, and we put down our numbers 2, 5, 6, 8. You just list them all out. You can see their values down here 2, 5, 6, 8. How do you go and get a specific number in the list? That is where you put the square brackets on the left side. You put it right beside here. This is called the index, the number inside. The index is telling you where to look inside the list. The 0th number is going to be 2. The first number is 5. The second number is 6. The third number is 8. And once you understand that concept, the world's your oyster. It's just another variable at this point. So we're going to say the numbers at 0. So take this spot right here and then change that into a 3 instead. And you can see that gets replaced. We can also go and say print numbers, square brackets, 0. And just in a nice big red text box for everybody to remember, we always start counting at 0. Good old-fashioned programming thing there. We always start at 0. Index is equal to 0. And don't tell me about those programming languages that start at 1. I don't feel like hearing about that. All right. There's a couple other functions that are really useful just to know for your lists. So if you want to go figure out how many things are inside a list, that's where you use len, L-E-N, and then you type in my list. And I'll give you a little cheat to remember here. The number of elements inside your list is always going to be 1 bigger than the biggest number that you can access. This is 0, 1, 2. How many is that in total? 0, 1, 2. That's a grand total of 3. That is the length of your list. How many do you have, or how do you go and add something into your list? You use append, drops it straight onto the end. Now you got a list of 4 things. How do you remove something? You use the remove keyword. You type in the thing that you want to remove. And so that's going to be the letter B. We're going to go and kick that out. And now we just have A, C, D. And how do you go and clear a list? Hopefully this one's pretty obvious. You call the clear function on it. You get absolutely nothing left at all. Okay. No programming languages start at -1. Oh boy, that's hardcore. I'm not going to use that. All right. As for list, how do you go and work with every element in the list? We're going to go and use the for loop. Loops are really good at repeating a piece of code. It will print it out over and over and over again. So I'm going to go and take my shopping list. I'm going to go to the store and oops, first the usual, take all this, comment it out, bye-bye. And we're going to go down to my for loop here. So I got my shopping list and it's, wow, spelling is important, kids. So we got eggs, we got our cheese, we got our bread. And I want to go and get shopping with them. What do I need to pick up from the store? For my item in my shopping list. What does this read? For every single item in the shopping list, do something with that item. In my case, print, I'm going to buy, comma, and I'm going to go and print out my item. Excuse me. So when we see that, we're going to go print out. I'm going to buy eggs. That is the item. I'm going to go and buy cheese. That is my item. I'm going to go buy bread. That is my item. I'm going to go and just hop down here with the while loop. The while loop is basically a way how to keep on running code while something is true. You can make code run forever. You can make code run as many times as you have elements in the list. You can make code run while you think that it's an important thing to be running. I believe the simple example I have here, while I is lesser than 5, that's a pretty simple one. I equals 0, while I is lesser than 5, print I. Now, what happens if I try running this right now? Any predictions what happens if I press the play button right now? Ooh. Let's see, any other answers? It's going to print from 0 to 4 or print forever. It'll be an infinite loop. No stop condition. It'll keep on printing I. What will it be printing? Infinites? Let's see what it prints out. And oh gosh, that was a terrible idea. It's printing out 0.0000004 ever and ever. I'm going to go cut that off. So what did it do? It printed out I, and it's going to be the first value of 0. Oh, wow. You know, it's such a bad idea. My computer is freezing up right now. You guys are still able to hear me? I'm going to go and shut this off. We're going to pretend that didn't happen. That's a lesson learned for you guys. Don't do that. I should have really practiced that before today's presentation. Now we know what happens. This window's no longer responding. Reopen that, please. Whoops. Wow. Okay. Programming lets you do anything. Anything. This time around, let's be a little bit more intelligent about that. I hear people here, oh yeah, we got to make sure that we don't print the wrong things. And holy smokes, my computer is running at 100% CPU. That tells you how bad an idea it is to have an infinite loop like that. So I'm going to go and type in I plus equals 1. Make sure that that does not happen. So bear in mind, in Python, there is no such thing as the I plus plus operator, which is, for those of you not familiar, equivalent to I plus equals 1. That, just for a quick reminder, that's going to say I add 1 to I and store that inside I. We use this plenty. Actually, I'll just leave that comment there. And what do you know? Time for another quick question. All right. So how many times does the word waiting get printed here? I'm going to give you guys another 2 minutes to tackle this. All right, I think that a lot of people are getting this really quickly, and I'm running a little bit behind schedule, guys. So sorry, I promised you 2 minutes. I think we're just going to start cutting this off. Let's give it another 20 seconds. We'll wrap it up right about here. I see a lot of answers coming in. Basically, everybody is getting this A-okay. How do you call an item in a list using its index again? You use that by using the square brackets. Good question. So you put the square brackets on the left side, you type in the number inside there. So my number is square bracket 1. And what do you know? Boom. This is a bit of an easy one for everyone to go and get. I don't know if you guys can see those results, but basically, yes, it is going to be 3. How does this work? Well, you take the light inside here, inside your traffic lights, and you're going to walk it through every single time. If the light is red, print out waiting. Otherwise, print out go. So first time, red, you put it in here, red equals red, waiting, red equals red, waiting, green, print go, red equals red, waiting, and then green equals 0. Start at 0. Ooh, that's a thing. When you got to look at a list, you're going to look at the length of it. That's when you use just good old regular intuition on how to count. So I counted off with my fingers here, 1, 2, 3 times here. If you're talking about the index being the position of it, that's where you start counting at 0, 0, 1, 2, 3, 4. So it also makes things handy for saying like I is lesser than 5 or I is lesser than the length of my list, because it always works out, but it's always kind of just a bit annoying. Index is where you start at 0. Length is when you always have the full regular intuitive counting. Okay, functions. Functions. This next most beautiful thing in code. So why do we use functions? Just as a quick reminder, functions go and make things packed up, reusable, and ready to go. In fact, they're kind of like the baby versions of objects, I'm going to call it. And I would just say that functions just make things so much shorter, so much easier to work with. So let's go get rid of this, pop that out. And we're going to go and put inside here our functions. If I'm going to say, for example, let's do x equals 1, y equals 2, z equals 3, and I'm going to go average equals 1 plus 2 plus 3 divided by 3, and now you just got to throw in some brackets around there. Actually, 1 plus 2 plus 3 is a terrible example. Let's swap it out with x, y, z divided by 3. That works fine. You do get an average if you go calculate it like this. If I want to go calculate the average for different 3 numbers, I'm going to have to type them all out over again. So I'm going to go with A and B and C just to make sure I have my new variables. And I'm going to type in A, B, C, and I can go and calculate the average again. Now, wow, that's kind of inconvenient. That's kind of annoying. Even if it is just one line of code, I don't really like typing that out over and over again. Instead, the better way of handling these kind of things here is to go and make a function. I'm going to go def average, and I'm going to open up my list of parameters, open my brackets here. These are the inputs, the variables that the function does not know, but the function can work with. I'm going to go and put in my 3 variables, my x, my y, my z, and then I'm going to go inside my function body. I'm going to tell it what to do. The average is equal, or I'm going to use a different name just for making it a little bit easier to read. AVG is going to equal to x plus y plus z divided by 3. There we go. I need to give this value back to the world when I am done. That is where I'm going to use the keyword return. When I'm done, I'm going to go and give back a specific number so that the user can use it. So now doing this, I can go average 1 is equal to average of 1, 2, 3. I can go average of 2 is equal to average of 4, 5, 6. And basically, you can see it here, that when you have a return value like this, you can basically treat this thing like a bit of a large variable. It just goes over here, it runs all this code, it gives you one number back, and it gets substituted right into here. So in this case here, this is the same thing as if I just chose to write average of 1 is equal to 1, 2, 3. The average is 2. So basically, it goes and condenses down everything, make it a little bit easier to read. Variables are, or functions are beautiful. And that was a bit of a crash course here, but just to go and point out the things that we need every single time, here's how you go and build your own function from scratch. You gotta have the def keyword, your brackets, your colon, nothing out of the ordinary there. You gotta have a name for your function here. So mine, that was average. You gotta have a body of the function. What is it doing? It's going to be doing some math. It's going to be putting some numbers together. You're going to have some functions that are only a few lines long. You're going to have functions that are really, really big. Hint, the small ones are actually a lot better. And then finally, we got a couple of optional choices here. You can have parameters. You can say, what is the input? What should I be calculating? Or what should I be doing with this thing? Parameters are super useful. And you saw me, I just separated them by little commas there. And then finally, the return value. If you want to give back a number, if we want to fake this entire thing as just a really fancy variable, then that's where you got to go return that number that you want to go and give back every single time. Okay, functions. Oh, wow. Here we go. Just another example just to walk us through here. All right, everyone, what is the name of this function? Add, excellent. I'm seeing a lot of people getting that right. Perfect. What are the parameters of the function? A and B, A and B, A and B, excellent. What is the function body? Sum equals A and B. Ooh, technically speaking, I think it might be bad wording on my behalf. So I'm going to go clarify. The function body is everything that's indented. So that function body also includes that second line, return sum. So the entire answer, function body, sum equals A plus B, return sum. And finally, what is the value getting returned in this case? Return sum, beautiful. Everyone's got it, perfect. You guys do me proud. And of course, you guys got to remember, you have to go and call your functions as well. So outside world is going to go plug in some numbers here. You go and call the function. The inside world does not care about anything of the outside world. The outside world does not care about anything of the inside world. It is like a cross, except for one tiny little gap. And that is where we're going to be going and passing our parameters here. So hopefully that review sounds familiar with everybody here. I'm going to jump into the next quick question here. There's something wrong about this code. What is it? I'm going to give you guys a minute, 30 seconds to think about that. Okay, 40 seconds left. I'm seeing a lot of answers here. Okay, I think we actually got the answers from everybody, if I can count the number of mentors correctly. I think we can go and wrap those up. Excellent. I am going to go and share these results here. And the results is my function doesn't return anything. So for those of you who got it, congrats. Very good catch there. We were trying to be sneaky about it. Return value. That's actually just a variable name. We actually aren't using the keyword return. Just to go and demonstrate, in the previous slide here, we actually literally say the word return. Kind of gives you a hint why you should go and choose reasonable variable names so that you don't get weird, tricky things. I saw a couple people fall for a couple small things here, like star equals is not a valid operator and nothing is wrong. Well, we obviously know that something had to be wrong, process of elimination, but the star equals operator, what is that? Star equals is just along the same family as the plus equals and all those other minus equals, divide equals, modulus equals. Those are all the same things here. So I equals 1, and if I go I plus equals 1, that is I equals 2. I times equals 2. From there, we're going to say I equals I times 2, which equals 4 in this case. We can go I divided by equals 2, which will just take us back down to I equals 2 again. We even have the fun ones like I modulus equals 2, which I think is really the interesting one here. It's really super useful once you learn how to do it, but we're not going to be using this one very often. It says I is equal to I modulus 2. Modulus, for all of those who need a quick refresher, is the remainder function. So 2 remainder of 2, 0. 1 remainder of 2, 1. 3 remainder 2, 1. 4 remainder 2, 0. It is a super useful function once you guys get a hang of it. And I should probably go and wipe out this variable here before it causes some more confusion later. Excellent. We're going to hit some new material now. So I'm just going to go and do a quick pulse check, make sure everyone's doing okay. How is everyone feeling about all the stuff we just reviewed? I went through it super fast, so don't be shy if you say that some of that was a little bit fuzzy. Feeling good? Everyone's feeling good? Excellent. Okay. Okay. If you're a little bit too shy to say that you aren't doing too good on that, go ahead, just message your mentor on that. On the other hand, if this is 100% way too far above your head, might be because this is the advanced sessions. We also have beginner sessions. If that is a challenge, go talk to me in private or go talk to your mentor. We can go get that sorted out. But everyone else who's doing good, awesome to hear so far. I'm going to be moving on to the new stuff here. So tuples are not that complicated. They're just a really weird word, but they're basically just like a list. Well, a list, but with a couple weird caveats, let's say. So tuples basically let you go and store a bunch of things inside there. A really useful example, I would say, it might be like a list of coordinates or a list of numbers. It is very similar to an array. I'm not going to use the word array because quite often in most programming languages, array is the same thing as a list. Tuples have one definingly different feature though. My tuple equals, let's use round brackets to create these rather than the square brackets. I'm gonna, oops, I got ahead of myself. I wanna show you what they do, just like a regular list here. With my tuple, you can go and grab the first number dot, like x equals my tuple of index number 0, just like a list here. You can grab the second one here, y equals my tuple at index number 1, and then I'm going to copy and paste that line and say that z is my tuple at index number 2, and I can go and print out x. Hopefully none of that's a surprise there. It is just like a list in that respect there. You can read it just fine, but tuples are different in one key respect. You cannot change the value inside a tuple. My tuple at number 0, let's say if I want to change it to 99, what happens? I'm going to run my code. And jeepers, that is an ugly error. It is, object does not support item assignment, or tuple object does not support item assignment. So it is immutable. That somebody has got the keyword there. For those of you who do not know, mutable means changeable. Immutable means permanently stuck like that once you go and create it. It is constant in other keywords here. So they're useful. Strange, right? How can a number that's permanently fixed be useful? It's super useful because you know that it will never go and change down the road by somebody else or something else down there. You can always promise it's going to be the exact same value that you started with. That's why constants are extremely cool. And tuples are just kind of an extension of that concept. So, whoa, okay, why can't I just use a list? Well, lists are good at organizing things that are basically identical. So that comes up to like a really interesting thing. I pointed out an example that tuples are great for coordinates. Let's see why lists are pretty bad at this. List is bad for chords. Equals, I'm just going to make a very ugly variable name here. Let's say the coordinates at 100, 200, whereas tuple is good for chords. Technically speaking, there is literally nothing different here. They work exactly the same. And if you're a smart programmer, you can avoid all the problems of that. If you're a smarter programmer, you can go and see there's an advantage of making sure that you know exactly what you're doing and making it so that you don't have to be smart down the road. The smartest programmers are the laziest programmers. They're the ones who set themselves up to be doing a little bit of hard work at the beginning so they have an easy time later. I want to go and highlight something here. When we go and take a look at like the numbers 100, 200, let's go and say instead of list is bad for two coordinates, I'm going to go and change that variable name out. I'm just going to call it absolute gibberish. I'm going to call this one some other piece of gibberish here. Oops, not with a semicolon though. When you take a look at these names here without any context, that's 100, that's 200. Well, that might be maybe two x coordinates like that. Maybe that's an x coordinate, that's a y coordinate. Maybe that's two y coordinates. I don't know. Lists are really good for typically the assumption that's the first x coordinate, that's the second x coordinate. With this other one though, the tuple, you're going to have to go and see here that, okay, maybe there actually might be a value. The first one means something different than the second one. And when we are going to be using Pygame, we're going to be seeing this a lot. For example, you're going to see x, y, width, height. Those are describing four completely different things, but they can be tossed together into a tuple quite nicely. In a list, honestly, that gets confusing. Good variable names. Mark, you hit the nail right on the head. Holy smokes, that is a terrible variable name. I really should not be showing anybody this. So I'm just going to call this list chord and tuple chord again, just so that you all can remember. Anyway, That's just a little bit of a rant on why tuples are super cool. So with that, let's go and take 10 minutes here. You guys get to go and meet your mentors again. And we're going to give you an exercise. I've given you a list of coordinates written out as a group of tuples here. So we got 1, 2 as the first coordinate. Second coordinate is 2, 3. Third coordinate is 4, 5. Fourth coordinate is 6, 7. All that's wrapped up into a list of coordinates. You're going to have to go and tell me which one is the smallest coordinate on the list. How can you make a program that can tell you the smallest coordinate for any list of coordinates I give you? Let's go for the X coordinate in particular. Just make it easy. Let's go and take 10 minutes right now, see how you guys can do.
Some of you are, again, not assigned to rooms. So if you aren't, just type in the chat which group you're supposed to be in.
Okay, welcome back. Let's see, do we have everyone back here ready to resume? I know I promised 10 minutes, but we are a bit behind schedule, so I'm going to go and pick up the pace just a little bit. How's everyone doing? How many of you guys were able to finish this exercise? Okay, sounding good. Anybody here who had troubles? Anyone who was not able to get this done on time? We got the idea, that's always good. I'm going to go and see if I could do a bit of a speed round for this here. We got chords is equal to a list of, oops, not that. And I'm going to type in like 1, 2, 2, 3, and 3, 5. We wanted to work with any number, so it doesn't matter. What we're going to do for chord in chords, we're going to go and take it, and we're going to go and say if chord 0, which is the first number on the list, is lesser than, lesser than what? Lesser than the biggest num. We're going to say, not less than, what am I doing? If the chord is bigger than the biggest num, we're going to say chord, or the biggest num is equal to chord at that spot. And you guys might be wondering, what is that biggest num? Well, that's how I like to think. I like to go and try solving the problem, and then I backfill, and I put in the important details later. What's the biggest number? Well, the biggest number here, we want it to be one that's not on the list. -1 is typically a good candidate. And I'm going to go and print the biggest num. Yeah, I kind of choose ridiculous names, but that's how I kind of think about it. Afterwards, when I'm done, I can go for a more reasonable name, like largest. And I'll go copy paste that in real quick. What does this read? We're going to go and take the largest number on, or we're going to start with the largest number, set it to -1. If any of our numbers are bigger than the largest one that we currently have, swap it out. Make the new largest number the one that we found so far. So I hope I'm getting this right. I, for some reason, thought it was smallest. The logic is still the same, though, with smallest and largest. And due to the time constraints, I don't want to hold us up much longer. Okay, we got the largest number is going to be 3. I think that I'm starting to get a lot of weird printouts here. Yeah, so I definitely went for the largest solution here when it's supposed to be smallest. The logic here is a pretty simple flip. You rename that variable to smallest. You flip this around here, and then you go and change this out to a ridiculously big number. I apologize for using largest versus smallest. Hopefully, on the other hand, though, you guys can see that it's just a simple reflection of the exact same concepts. I'm going to put it back. Here's the answer for largest, just so that you guys can pause it and review it in a bit of a common sense way. Okay, dot operator. This one's actually pretty intuitive. I'm not going to spend much time on here. The dot operator says when you have a something and you want to do a specific operation on it here, you can use the dot operator to go and apply here. So if I have a shopping list of just basically good old list, you can go and append milk into it. You can go and remove milk from the list. So basically the dot operator is saying, do the action on the thing that comes from before. Okay, yeah, good call, Alejandro. Thank you for that. I had just a bit of junk here. This is why you typically space things out. Don't use the same file for everything. You can use the dot operator for multiple things here. This is going to be really useful for objects and modules. We haven't seen those yet, but we will, I promise you. If we have a dog object, which is a very fancy variable, you're just going to have to trust me on that. You can talk about its left paw. You can talk about its right paw. These might be two separate, distinct things. And then when you want to say move, what do you want to move? You want to go and say move the left paw or move the right paw. Doesn't make sense now? Don't worry. We're going to see plenty of examples in this in the future. Like in Pygame, we're going to see that Pygame here is a module, which is a lot of code that's already written for us. And we're going to see it get initialized. We're going to see Pygame take the images from it and we're going to load it. We're going to go and see a lot of it. Either way, whenever you type in Pygame, you're going to just need that little dot right there. Just remember that, folks. Speaking of, let's jump into the fun part here. We're going to go and make your life easier. There's a lot of code. I don't like memorizing it. So I'm going to go and say, let's go and grab a link here. I'm going to link you directly to this particular page. Wow, that is a lot of code. So let's go to everyone here. If you all could please follow me, go to this link right here. And this is a lot of plain old code. We're going to be using this. I'm going to go and right click this and we're going to go and download this file. This is the boilerplate. This is a template code that we're going to be using every single time to make our lives a little bit easier. You can honestly just simply do save as, and it's a Python file. I like the name, main copy and rename. And I'm going to keep with that big name here. It's a bit of a noxious one, but I want to go and prove a point here. Remember, we made this Ignite sessions folder yesterday. We're going to jump inside there. I'm going to plant this link, main, copy and rename, just like that, right inside here. So inside my folders, when I am done with that, we can see main, copy and rename is living here. Why do I keep it this terrible, terrible name? Because when I go and take it here, I need a reminder to myself. And I'm going to pop it right into here. What did I do? I just went, I copied it, I pasted it directly inside here. That's the copy. Now we do the rename part. I'm going to press F2 on my keyboard. That's open up the rename. You can click and hold, or Mac users press enter. And now you can choose a more sensible name, like main. This is where your program starts. You take a look at VS Code here, and boom, pops up over here. We're going to go and take a talk about this here. But first, I want to confirm, does everybody have main, copy, and rename downloaded on their computers? Good, good. Excellent. Looks like everyone is doing really well with that. Once again, reminder for those of you who might have lost it, you go to this link right here. You go and press save as. You save it wherever you want and make sure you name it main, copy and rename. Put it inside your Ignite sessions folder. When you do that, every single time, we're going to be repeating this process a couple times down in the weeks. Copy your file, jump into your session 1 folder, paste it inside there, and we get to go and use it every single time. And finally, rename it to something sensible, main.py. We should all start seeing code that looks a lot like what we have on my screen here. And I want to go and highlight 4 major sections of this code, how it works. The first is called setup. The second is events. The third is updates. The fourth is draw. So these are the 4 major sections, the 4 big ways we're going to think about it. It's not a rule of thumb. We just decided to go and organize it this way, just to keep ourselves nice and tidy. I'm going to start right from the top here. Pygame has a lot of code. Some of it needs to be set up properly. You don't want to type it all out by yourselves, so you got to use pygame.init to set it up. Afterwards, I'm going to skip down a couple lines here. Skip, 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 skip. I'm going to go and see this thing called clock. Clock is going to go and set up a little timer for us. You guys all saw what happened when I said while in an infinite loop. It ran really, really fast. We're going to use the clock to go and slow that down because we got a while true loop. I'll come back to that a little bit later. Finally, the part I did want to go and explain that I skipped over, it's called the screen variable. The screen variable is going to be like your canvas. It's pretty much where you're going to be painting things onto your screen this entire time. It's, for my sake of example, it's going to be the piece of paper where you're going to go and put everything onto it. Finally, we're going to need to go and get that stuff showing, but I'm going to get back to that in a second. Let's go and take a look at the events section. The events basically are things that happen whenever the user goes and does something that the computer does not procedurally know about. It's called an event. Some classic events is when you go and click on your mouse, or when you go and press a key on your keyboard, or when the user presses the quit button. So yes, that's right. You guys are responsible for making sure you press and check for when you press the quit button. Pygame needs to know, what should I do when the user closes the game? That is the quit event there. And it says, just call off this magical piece of code that says quit, wrap it all up for you. We'll come back to this later. We'll see more events in the future. Okay, I'm seeing some people here that are asking some questions. Some people have worked with Pygame before. Do we need to do pygame.locals import star? Well, you can import Pygame in its entirety here. There are multiple ways how to go and import things. With Python 3, it simplifies things. We got somebody saying module not found, no module named Pygame. Sanchit, if I remember properly, you might have been running into Python 2 issues before. Remember, we are on Python 3. So if you're on a Mac, you're going to be typing in Python 3 -- or in Python 3 to go and run your commands. If you're on Windows, you're going to be using py-3. I definitely say go talk to your mentor, see if you can go get that sorted out. You'll need to go and run pip install Pygame. Yes, please install Pygame. Pip install Pygame. So just as a reminder, pip install Pygame, that's typically the command you need to run. Or if you're on a Mac, you need to do pip3 install Pygame. That's all in session 0. If you're still struggling with that, go talk to your mentor. I'm going to carry on just because we're still short on time here. The update section is completely blank. There is nothing here at all. The update section is where we're going to go and make the brains of our code exist. Well, of course, it's empty right now because we don't have any programming to show you yet. So that is why we have nothing in here. But I can show you a simple example. I can go like x is equal to 0. And the brains of our logic, let's say we want it to always be increasing, we go x plus equals 1. This is something you go and put inside your update section. We're going to be seeing plenty of examples of this in the future, so don't worry about it right now. I'm going to go delete this just to go make things a little bit more organized. Finally, drawing. We need to go and draw some stuff. And I say we have our screen. I mentioned the screen is our canvas. I do want to distinguish that first up, you can go and paint on it. Screen.fill black. This is, if you scroll up, take a look at the definition here. Black is a tuple. And you can see that it's open bracket and we got RGB. This is the way that Python expects it. This is the way, sorry, just add to. If you guys are curious, why do we have this capitalized thing here? These are constants. These are things that don't change. Fun fact, that's called Screaming Snake Case. If you want, go look it up. It's kind of cool. That's just the format of where you do capitalize and underscore to separate your words. It means please don't touch it. We got white as well, just as convenience, but we're not worrying about that right now. We're going to go paint the entire screen black. It's as if you go and take the big paint bucket tool on your favorite paint editor and wipe the entire screen black. So if you accidentally go and do anything up here, it's like, for example, screen, if you try drawing a rectangle, pygame.draw.rect, just know in mind here, it's not going to work. It's going to disappear. So afterwards, we're going to go and start drawing more stuff after we paint the entire screen black. And you know what? It's a great time. Let's type that again. Pygame.draw.rect. That's for a rectangle. What are we going to go and draw in our rectangle here? We're first going to go into to say, wait, where do we paint it? Where should we put it? We're going to put it on the screen. We're going to go and next type in what color do we want it to be? Well, I have already white available. If you guys want a different color, you can always open up your own tuple, open bracket, close bracket, and I'm going to go 25500 RGB. Anybody out there know what 25500, what color is that? Perfect. You guys are paying attention. Excellent. That is red indeed. Finally, I'm going to give it the coordinates. I'm going to go and tell it the x, the y, the width, the height, all bundled up together in a single tuple. We're going to go and do that here. We're going to say the x coordinate is 100, the y coordinate is 200. From the top, I'm going to remind you, the width here, I'm going to say is 50. The height here is going to be 30. We can go and draw that out now. We can go and see that in action. Boom, got a nice little red rectangle here. A couple other things to point out, pygame.display.flip. This is where you go and take your piece of paper, you smack it into the computer. It's actually how you get it to go and show up on the screen. You can read up on it, but I'm not going to explain the details. Finally, tell the clock to go forward and wait for a little bit, just so that it doesn't spend absolutely forever. How are we displaying stuff about pygame.display.update? Great question. Pygame.display.flip does the exact same thing there. So it actually has a technical little difference. I'm not going to spend today talking about that though. Okay, I do want to say that these numbers here, that's hard coding. And for those of you who knows what hard coding is, you guys know that's when you put numbers straight onto here and you're going to be trying to remember what those mean. Typically a bad idea. Another way we can do this is if we have a rectangle object. Yep, we're going to go and teach you guys objects a little bit early. So I promise that that is going to be next week, but we're going to get started right now. What I'm going to do is say we have my rect is equal to pygame.rect, capitalized R here. And now we can see a list of numbers that we can go and put in here. This is just like a function, but we're going to actually see that is slightly different. How do I stop the program from running? You can just close the window. It will shut the app down or the program down. Okay, we can see left, top, width, height. Left is same thing as X, top is same thing as Y. Remember, starts from the top left. I hope I'm getting it correct, the direction with my mirroring. But let's go and say I want maybe 300 to the left. I want it to be 65, 67 from the top. I'm going to go and set the width. I'm going to set that as 100. I'm going to set the height as 200 tall. This is now an object. Capitalized letter R means create that object. We're going to go and give it some information on how to get that object. Interesting. Jonah, definitely go take a chat with, or ask your mentor about that, how to go and close your app if it keeps on reappearing. That is kind of unusual. I want to go and emphasize though, 367, 100, 200. If I don't draw it, it's not going to appear. I'm going to comment out this line of code just to prove that point. I'm going to draw absolutely nothing. My rectangle here is not being drawn yet. How do we go and draw this thing? We're going to go all the way back down to our draw section, scroll down, and I'm going to go and type in pygame again. Pygame.draw.rect. It's actually a bit special. We're going to tell it the same thing. I'm going to tell it the screen. We're going to tell it the color. This time I'm going to make it green. So maybe a nice lime green, 255, 100. But this time, it lets me go and say, hey, would you like to put a rectangle object inside there instead? And I would say, yes, I'd like to do that. That makes my life a lot easier to read. So pygame.draw.rect. I'm going to put it on the screen. I'm going to paint it green. But this time around, I'm going to draw my rectangle here. It's going to go and automatically fetch all the information from you. It's going to know exactly where to draw that. There we go. Big, green, lovely rectangle here. Excuse me. What we can also do here is start manipulating it a little bit. So the rectangle is special because it has a couple properties built directly into it. My rect dot x. That is just a variable name saying the x coordinate of it. Maybe I'm going to say I want to put it at 101. My rect dot y is going to also be another number here. Inside my update section, I'm going to update this number to be somewhere else. Instead of 67, let's make it, I don't know, let's put it way down, further down my screen. 400. My rect dot width, I'm going to go and set that to be a little bit wider. So I'm going to make it maybe 400 wide. My rect dot height, I'm going to go and make that a smooth, slim 50. I'm going to get a nice little rectangle drawn a little bit further down my screen. Pop that into there, and boom, we got that. You know, that looks like a really good platform to go and play a game on. Sorry, spoiler for a future week here. What we can also do, I'm going to go and show you the last cool part. Instead of just simply setting it to a single solid number, this here is a variable. myrect.x, specifically the x is the variable, I can start playing around with it. Have some fun. For example, I can say plus equals 3. It's going to say take my rectangle, get the x value from it. I'm going to add 3 onto that x value and put it back inside my rectangle's x value every single time. What does that give you? Well, when you run that, you should get the classic rectangle running off the screen. You can start manipulating anything you want here, and you have a really concise way of doing so. We're going to talk a lot more about this in the future, but my other rect is a way that you can go and create multiple rectangles on your screen. You can just start typing up some other stuff here. 100, 100, 100, 100. I'm just going to get a little bit lazy with that. I'm going to draw my other rect down here. I'm going to copy, paste this entire line of code here. And instead of my rectangle, I'm going to go my other rect. So one more time, this is just simply me having a little bit of fun. I'm making a second rectangle on my screen. Not going to update it. I'm just going to put it right here. And intuitively speaking, what happens? Well, we got my rectangle and it's going to get moving. My other rectangle, nothing's going to happen to it at all. Maybe I'm just going to paint it a different color just so it's a little bit obvious. And there we go. My first rectangle slides away. My other rectangle, solid block right there. Let me go back to my slides. I know that I've abandoned my slides completely at this point here, but hopefully we are all following along. Recap here. We first go and grab that main.py file. We got plenty of instructions for you to follow along with if you want to go and recap how to do that. And then afterwards, we got the 4 sections here. We got the setup section. Things happen here once we're going to get setting stuff up here. Inside our infinite loop, the while true loop, we have to check out if there's any events coming in. When they happen, do something. We're going to take a look for the update section. This is where we put the brains of our code. We make things happen. And then finally, we're going to go and draw stuff. So we have ran through all of this here. I am going to go and skim through to give you guys a little bit more time on your exercises here. And sorry to all those content development members who spent forever making those slides just for me to whip through them real quick. If you guys ever want a color picker, fun fact, you can just simply Google a color picker. And there is one right there for you. So if you don't like memorizing RGB, you can just simply go slide around and find RGB right there. Very useful if you ask me. Back at it. We have drawn our first rectangle. Inside the setup section, we're going to go pygame.rect. You can use hex codes. I'm going to double check the answer to that. The answer is probably yes, as long as you go make it a string and you put a hash sign in front. Hex code is just a different way of representing your colors. So inside here, rect equals pygame.rect. We see red is a tuple. That is a constant as well defined here. And inside the draw function, you can put your screen where you put it. You put the color, just take that tuple, slot it right into there. Get wrecked. I can absolutely see get red rectangled. And then finally, you go and tell it, where do you want to draw it? You're going to go and draw your rectangle. Okay, we've also taken a look at this. You can access the variables any way you want inside here. You got your rectangle.x coordinate, rectangle.y coordinate, rectangle.width times equals 30, multiply it by 30. I don't know why you do that, but that sounds like a lot of fun. And really, it's just repeating a lot of stuff we've seen before. So at this point here, we're going to go and give you guys the first breakout. I wish that we could make it a little bit longer, but this one here, we're going to go and make this slightly different than all the future breakout rooms. You guys got 15 minutes to go and do whatever you want, which is try out this challenge here. Normally I'd bring you back together and we can talk about it at the end, but I think that right after this lesson here, we'll stop at 7:30 and let you guys go. So how about it? Let's get jumping right into it.